clients that you have, and then you talked about some of the modeling that you did for them. How I see Dynex, or how I saw Dynex originally, was that it was strictly number crunching, but when you bring up models, it always makes me think of AI. Can I personally get some clarification on the differences between what Dynex does versus what some of these other compute resource companies do in regards to number crunching versus AI modeling?
So you're talking about like things like large language models, for example.
Yes. Yeah.
And things like ChatGPT, Llama, and that kind of thing, right?
Yeah.
So we are in the process of bringing out our own. So Chris has just Chris has already.
That was convenient. Yeah, that's why I brought it up.
There you go. Yeah.
Thanks, but we're working on something that will be effectively the very first quantum-based LLM. And that's quite tricky in a quantum environment because there's variables that have to be translated from a quantum formula to something that a computer can actually read and use. We've already demonstrated something called QNLP, or quantum natural language processing. That's the fundamental underpinning that is the talking mechanism between you and, say, a ChatGPT. And that's where basically the large language model plugs into. The next was obviously transformers. Those are the things that can actually give it actions to do. So you tell it to write a piece of code that needs a transformer in order to, translate all of that into a format that's usable. So we're almost there. We think we'll be there by the end of the year. And then it's going to be a case of seeing how fast we can train ChatGPT. We know roughly how long it takes, the big players in the industry to train their models. It's weeks, if not months. What if we could do it in under an hour? That would be pretty impressive, right?
Yeah.
So it's something that we're working on.
Okay.
But in relation to what you said about like where do we stack up compared to others? So a lot, the rest of the compute sector, right, are all working on standard traditional models. So that's very much computation like we're all understanding right now. One action in, one action out, blazing fast, but it's still one in, one out. Whereas what we can do is go, I need to do 100 variables and do them all at the same time. And then they all come back at the same time. So think of it like a big spider's web at that point, right? We can spider web out to a much bigger search pattern than what you can with normal compute.